Suppose an object has a constant acceleration given by a, along with an initial velocity of v sub 0, which we usually call v naught, and an initial position of s naught. Find a formula for its position as a function of time. All right, so we're told that the acceleration as a function of time is some constant a, and we want to figure out the position function. So let's antidifferentiate. The antiderivative of acceleration is velocity. The antiderivative of a is going to be a times t plus a constant. But we know the initial velocity is v naught. So the velocity at time 0, which gives us 0 plus c, or just c, equals v naught. So we can replace c with v naught. So the velocity function is the acceleration times time plus v naught. And if we want the position function, we take the antiderivative again. So the antiderivative of t is t squared over 2. I'm actually going to write that as 1/2 t squared and put that a in here. Just a little bit nicer this way. So 1/2 a t squared plus v naught t, because the antiderivative of a constant is that constant times the variable, plus another constant term. But we're told that the initial position is s naught. And if we were to look at this position function when t is 0, these first two terms would go away and we're left with d. And since the initial position is s naught and the position when t is 0 is d, that means that those two are the same. And so we end up having 1/2 at squared plus v naught t plus s naught. And this is our final answer. And it is actually a general physics formula for a situation where we have a constant acceleration and we know the initial velocity and we know the initial position. And so this is what we get. This is used in many physics classes, and you can use it now. If you know that you've got an object with a constant acceleration and you know the initial velocity and you know the initial position, you can plug those things in here and you've got your position function.